My name is Bo Bonnell, and I'm with the U.S. Geological Survey Great Lakes Science Center, and we are in the middle of our summer cruise to understand food web linkages in the Great Lakes, especially in Lake Michigan during this CSMI year. So we're asking the question, do sites in Lake Michigan that are adjacent to tributaries, are those more productive than other nearshore sites in the Great Lakes that don't have tributaries that load many nutrients into the system? And then secondly, we're not just looking at the nearshore, but also looking at offshore sites adjacent from those nearshore sites. So if there is, as we expect, greater productivity in the nearshore adjacent to high-loading tributaries, we want to see if that positive productivity carries over into the offshore or not. Or maybe the offshore is just one sort of well-mixed system that's not at all related to the nearshore. So we're really sampling multiple trophic levels, beginning with how much phytoplankton is in the water, moving up into zooplankton and mysids, and then even we're doing some benthic invertebrate sampling on this cruise. And then finally we're sampling fish, trying to get an estimate of fish densities, and those tend to be what we call the forage fish, or benthivorous and planktivorous fish that feed the salmon and the trout. So those are really the trophic levels that we're sampling at every nearshore, intermediate, and offshore station. So in general, managers are moving more towards something called ecosystem-based fishery management, and that's just the realization that we cannot manage fisheries in isolation because these fish populations are influenced by how much prey they have to eat. Be influenced by climatic factors that can influence their own survival or growth, and then ultimately they're also going to be influenced by the number of predators on that particular fish population. So by sampling the entire food web, we feel like we get a more holistic picture as to what are the key drivers influencing those fish population dynamics. It's surprising because most people think the Great Lakes are so valuable and gosh, we put all of these dollars into trying to understand them, but it's a really complex system to understand because so many things are changing at the same time. You think about invasive species or climate, declining nutrients, all of these things make it really difficult to tease out what are the key drivers because it's not like an experiment where we can hold one thing constant and just isolate that effect. So my overall goal is to try to understand to what extent invasive species are really influencing the Great Lakes and trying to have a better understanding of how things like spiny water flea or quagga mussels are really influencing nutrient dynamics within the lake that can either benefit or be to the detriment of fisheries.